Ladies and gentlemen, space fans, conspiracy enthusiasts, people who stumbled upon this video while looking for other videos they couldn't find. Tonight's mystery. Why does the shadow of the moon during a lunar eclipse sometimes look like it's coming from the wrong direction? Let's explore this. Hello there, welcome back to Star Stuff, where it's kinda nice here. Things are easy to understand, and you're free to say whatever you want, while facts remain facts. So flat earthers say this proves the shadow in an eclipse cannot possibly be Earth's shadow. Apparently Earth is innocent. The moon has been shadow shamed by something else. Maybe a mystery object. Maybe a shadow goblin. Maybe the cosmic equivalent of someone turning off the lights during hide and seek. But today we're going to show that the explanation is very simple. No secret objects, no hidden planets, just geometry. First of all, a lunar eclipse happens when three things line up perfectly: the sun, the earth, and the moon. In that order. The earth blocks sunlight and casts a shadow into space. That shadow has two parts: the umbra, which is the dark central shadow, and the penumbra, which is the lighter outer shadow. When the moon moves into the umbra, we get a total lunar eclipse. That's when the moon turns that beautiful deep red color. Not because the moon is embarrassed, but because sunlight bending through Earth's atmosphere paints it red. Now here's where the confusion begins. Some people notice that during the lunar eclipse, the curved shadow on the moon sometimes looks like it's coming from the side, not from where the sun is. And they say something like, "Ha, see? That shadow isn't coming from the earth." Which sounds dramatic. But there's one tiny problem with that claim. Actually, several problems. But the biggest one is they're ignoring perspective. When we watch a lunar eclipse, we're standing on the earth, looking at the moon. But the sun is not behind us like a flashlight. The sun is very, very far away, and the geometry is happening over hundreds of thousands of kilometers away. So what we see from Earth is not a perfectly straight view of the shadow. It's angled. Imagine shining a torch or a flashlight on a ball. Now move your head side to side. The shadow on the ball will suddenly look like it's coming from a different direction. But nothing changed. The light source didn't move. Only your viewpoint changed. Congratulations. You have just performed the world's cheapest lunar eclipse experiment. No rocket required. There's another important factor. The moon's orbit is tilted about 5 degrees compared to the Earth's orbit around the sun. That means lunar eclipses don't happen every month. They only happen when alignment is just right. And during that alignment, the moon may approach the shadow from above or from below. So the shadow slides across the moon at an angle. To us on Earth, it can look like it's coming from the side. But in space, everything lines up perfectly. Now here's the ultimate awkward part for flat Earth. During every lunar eclipse, the shadow on the moon is perfectly round. Every time, every eclipse, every century, for thousands of years, and there is only one shape that casts a perfectly circular shadow from every angle. A sphere. Not a pancake, not a frisbee, not a cosmic dinner plate. A sphere. And the only big spherical object sitting between the sun and the moon during a lunar eclipse is Earth. This isn't new information. The ancient Greek philosopher Aristotle noticed this over 2,300 years ago. He observed that the shadow on the moon during eclipses was always curved, and he concluded, hey, maybe the Earth's round. Meanwhile, in 2026, some people are still saying, it's a shadow goblin. Another visual trick is rotation. As the moon moves through Earth's shadow, the curved edge can appear rotated relative to our horizon, because the moon itself is tilted relative to us in the sky. So what we see is a rotated slice of the shadow, kind of like taking a bite of a cookie. While someone slowly rotates it, the bite didn't change. Your angle did. So when someone says the shadow on a lunar eclipse comes from the wrong direction, what they're really saying is, I forgot that space is three-dimensional. And space deniers often imagine the universe like this. But the real situation is this: a dynamic, tilted, moving system across hundreds of thousands of kilometers. So once you look at the actual geometry, the mystery disappears instantly. So next time someone claims the shadow on the moon proves the Earth isn't round, you can tell them the explanation isn't mysterious. It's not NASA's secret trickery. It's just perspective and orbital geometry. And if you still think a mysterious object is casting a shadow, please let astronomers know, because discovering a new invisible planet that only shows up during eclipses would probably win you about 6 Nobel Prizes. Until then, the shadow belongs to Earth. The geometry checks out, and the shadow goblins remain unemployed. Thank you so much for watching. If you enjoyed the video, please like and subscribe, and share it with anyone else who might be a little confused when looking at a lunar eclipse. Cool beans!